examining 3D shapes, the volume of 3D shapes. Okay, 3D shapes or three-dimensional shapes are solid shapes. Their other name they are called are solid shapes. We have looked at 2D shapes, that's two-dimensional shapes. So this class we are examining three-dimensional shapes. We want to look at examples of shapes that fall under the three-dimensional shapes. Plane shapes are the 2D shapes. They are the flat shapes like your triangle, your rectangle, square, circle, your square, and the likes. But these ones, they are a little bit more complex than the normal plane shapes. So they are called three-dimensional shapes, or you call them solid shapes. So number one is the cuboid. Look at this. This is an example of a cuboid. You have this in some of these seasonings that you use at home. The formula for finding the volume, because we are strictly looking at the volume of the solid shape this class, we want to look at the volume. This column is for volume, this column is for cross-section area, that's CSA, while this is for total surface area. But we are not going to be concerned with this the cross-section area and the total surface area. We just want to look at, restrict this class to finding volumes alone. So this is the volume. Formula for finding the volume of a cuboid is length times breadth times height. Length times breadth times height. So that is what is the formula for finding the volume of a cuboid. Your length times breadth times height. Okay, we'll come to examples later on. This is a cube. This is a cube. I'm sure you have seen a cube before. You have ice cube, you can have ice cube, you can have Maggi seasoning cube, and like. So the formula for finding the volume of a cube is a raised to power 3, because each face of a cube is a square. So any side they give you, whether this edge or this edge, they all have the same measurement round. So that's why it's just a raised to power 3. If here is the part they give you, let's say 6 centimeters, we just be raised to power 3. 6 times 6 times 6 will give you the volume of the cube here. Then we have your cylinder. The formula for finding the volume of a cylinder is pi r squared times h. That's the formula of the circle times the height. The formula of the circle that is on top, the formula for the area of a circle times height. So that's why you have what? Pi r squared times h. Pi r squared h will give you the formula for finding the volume of cylinder. Okay, the formula for finding the volume of a cone, look at it, is 1/3 times pi times r squared times h. Okay, let's just look at all the volume and the formulas, then we'll come back to examples. This is a sphere. This is the shape of the earth. The earth is spherical in nature, so the earth is an example of a sphere. The formula for finding the volume of a sphere is 4/3 times pi times r times r times r. 4/3 pi r cube. That's the formula. This is an hemisphere. Hemisphere is like sphere divided into 2. So you have 2/3 pi r cube. That's the formula for finding the volume of an hemisphere. Let's move forward. Okay. Look at this. These are more examples, and I've spoken about cube before. So this particular example is using each of the face to represent s. Remember the other one I showed you shows a raised to power 3. It's still the same thing. If they give you s, is just saying one of the sides raised to power 3. So we give the volume of a cube. So it's still the same thing. Then the sphere, like we have considered, yeah, look at it. 4/3 pi r cube is the volume of a sphere. Then this shape is called tetrahedron. It's a special pyramid consisting of 4 congruent equilateral triangles. So it consists of 4 congruent equilateral triangles. It's called a tetrahedron. I think something like this is in one of our assignments. It's a question in the assignment. So it's a tetrahedron. It's a special pyramid consisting of 4 congruent equilateral triangles. Look at all the triangles that form this pyramid. They are all equilateral triangles. That means all the sides are equal. Look at this triangle here, this other triangle, then this triangle, and this triangle. So this is called a tetrahedron. octahedron. Okay, let's proceed. Okay, so let's look at further examples. Look at this. This shape is called a prism. It's a prism. 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 What's the formula for finding the volume of the prism? Cross-sectional area times length. Where is the cross-sectional area? This is the place where you have the intersection here. Look at it. This is like a square prism. Look at it. So that's a square face here. Look at that. So you have the cross-sectional area times length. That is area of the square times length. We give you this. If you are given this in a question, when you first find the area of this place, that's your cross-section, then times length, it will give you the prism, the volume of the prism. Okay, so you have this place too, is a cone. 1/3 times pi r squared times height. We give you the formula for this. Then a pyramid, 1/3 times length times width times height. We give you the formula for finding the volume of this pyramid. 1/3 times length. See your length here. Then this is your width. Then this is the height here. Height, how high the pyramid is. So once you just slot all the figures in place, you'll be good to go for finding your volume. And this is a sphere. 4/3 times pi r cube is the formula for finding the volume of a square. Of a sphere, sorry. Why you have your r as the radius of the sphere. So 4/3 times pi times r raised to power 3. We give you the volume of a sphere. Let's proceed. We have looked at this before. I've also looked at this. So I think finally we want to look at this. The volume of prisms and their formulas. You can have different types of prisms. You can have triangular prism. Look at this. This has a triangle face. So you can have a rectangular prism too. This has a rectangular face here. Look at it. Then this is a prism also that has like a circle. Look at it. Prism height is represented by h. So what's the formula if you are given this type of question? If like we have in the assignment you are given this type of prisms, now if you want to find your volume is length times width times height. This is your length, this is your width here, whatever the right is your width, and then here is your height. So you just multiply your length times width times height. We give you the volume for this type of prism. There is a rectangular prism. If you have a triangular prism, your formula is going to be, the formula for the volume will be the formula for finding the area of the triangle times the prism height. So it's just going to be half base times height, then times the prism's height, which is a capital H. The other H is this place. The number height is the height of the triangle. That is the smaller h. The height of the triangle that is the face of this prism. Then the normal prism height is the bigger h. Look at it. So the formula for finding the volume of a triangular prism such as this is half times base times height times the prism height. Look at the prism height. This side is your prism height. Okay. So then if you are given something like this, look at it. So this is pi r squared h, with like the area of the circle times height. So pi r squared h. Pi r squared is formula for finding the area of a circle. So the circle on top of it here is the pi r squared h. Pi r squared then times the prism height. Look at the prism height here. So pi r squared h is formula for finding the volume of this type of prism. Till I come your way next time. Bye bye.